Today, we'll discuss the pointer concept in C because C is developed in 1960-61 by Dennis Ritchie and Ken Thompson. The pointer concept gives very powerful component of C, powerful features of the C, still is unmatched in any other languages, even Java, Python, and modern day languages. Only C++ can match it, and that is basically enhancement of C, and that is one of the fastest compiled language, C and C++. The what is the basic thing is that we say procedural programming main calls functions, function call functions, any other functions. So you any program does the calling functions and how to pass the arguments or parameters to call from called function to calling from calling function to called function by the passing the parameters. If the parameters is actually the copy the whole thing, that is very slower, that is call by value, and call by reference you can pass the reference, that is the you can pass the pointer value, that is the origin of this is the address of, and this is the address of operator, and this is the dereferencing star. And how you declare a pointer? You declare a pointer by this kind of declaration, but one thing, this pointer is not a keyword. It is better to declare a pointer by ptr underscore or p underscore, like this kind of naming of the variable, because whenever inside the program you can by the name of the variable you can see that it's a pointer type variable, because star will not be visible at that time. And one of the best way to declare pointer, either actually by address of, like address of this is the this thing, or null. Whenever you are not sure about the which variable to points to, it is better to give a null. Not to be zero, because null is zero here, but it is a much better documentation. It is defined in the header files. So that is Dennis Ritchie. Why he has developed pointer? That is, he want to make it the fastest. At that time, whenever he was working, he has Ken Thompson working on PDP-8 machine in 1960-61. Rather 59, 60, 61, only 4 kilobytes RAM is there as a main memory. So he cannot, they doesn't have a luxury to by call by value for sometimes, and for faster data processing. Say if you want to a big character array or big array, so it is call by reference is much quicker than call by value. This is C pointers. This is the declaration, this is the declare pointer, but it is always, whenever you declare a pointer, it is always better to equal to null, and this is also doesn't give any error, but it is better not to pay, and there you actually address of it is come. So this is pointer declaration. It is two way you can do it. One can do it, this is null, and another is actual value. This is the difference between call by value and call by reference. Call by value is slower but safer, and call by reference is much faster but bit risky. See here the call by this is call by reference. If the coffee mug is filled it up, and it is automatically filled it up with the original variable also. But in call by value is much safer. If you send a blank unfilled coffee cup, and it will be filled up here, but it will not reflect here. So call by value is much safer. By call by reference, or whatever is done in the target variable automatically reflects here. This is pointer variable definition, like I have detailed books. This is, you can signify pointer by pointer, maybe at the beginning, or ptr or p underscore. This is, they have declared in like ptr here, but some way you can, from the variable name you can see that it's a pointer type. It is a preferred practice, and this is always better to have a null point. If you declare you are not very sure, so it is better to have a null, and a null pointer points to nothing. So if you dereference any null pointer, you might unexpected errors in the program. So don't dereference like star operator of the null pointer. Declaring pointers, same thing. There are the various types of pointers like integer pointer, floating point, char, double, long, and pointer variable naming I discussed. It should be some ptr pointer like this, and always better not to declare the pointer type and the variable type is the same. It is always better to have a separate declaration statement for pointer type and variable type. It is a preferred practice. And there's a joke meme here that is pointer is nothing but some addresses, hexadecimal addresses. So that's it. Null pointer, we have told that null pointer should not be referencing, like it points to nothing. And there's another meme like this null pointer in nothing, null pointer nothing. So a pointer is a null pointer is nothing, and initializing a pointer 0 is not a preferred choice in documentation. It is always better to use null. It is defined in the C header files. Pointer operator address of is one operator. See here, say is a pointer. It is a see it points to integer pointer like this in the first picture. This points to integer, and this is a void pointer. We'll discuss about this void pointer. Void pointer is such a pointer. It can be casted to any other type of pointer. It has whenever you want to dereferencing that pointer, we have to cast it by integer or float size that. And in void pointer is such a pointer, it can be target to from any other pointer like integer pointer, float pointer. We can remember that in our malloc and calloc operation, the return type is always a void pointer. Whenever so void pointer is very interesting scenario. We'll see it. And there is null pointer and void pointer, completely two different things. There are another two pointers we'll see. That is we'll discuss the next. Indirection operator, the star operator, and it is dereferencing we should not use for null pointer. Aiming at pointer array, and this is very interesting. The passing array, you just give the two way you can say. You can pass the only the name, or you can pass or 0th element. So this is very interesting passing array by the first element. That is the picture it shows there also. Adding integer a pointer like here, it is a whenever the integer, most of the integer representation in C compiler is 4 bytes. So we see here the 4 bytes. Here in the picture is a 4 bytes is there for, and if it's a char pointer, it will be 1 byte. Float, it will be 8 bytes, like this. So always pointer will increase or decrease by the which type it is. It is a char pointer by 1 byte. If it is integer 4 bytes, it is a float is a 4 bytes, like this. Subtracting same, and is here I will show the picture the float. It is in 8 bytes. Subtracting from pointer to pointer, it is not preferred choice because it can be only worked in a same array. So this should not be the practice. This is the error is there. Assigning pointer to another, you can do it. But it has to be casted, like pointer to void, it can be done. Say here the void pointer, and comparing pointer should not be done. It should be error. Sometimes it work in the same kind of array, but it should not work. Void pointer is an interesting pointer. Void pointer and null pointer totally different. Void pointer parameter, void start pointer must be always be casted. Like here we can see the calloc operation, malloc operation. We see it here. Yes, this is the pointer. This is a pointer and this is a malloc. And malloc with return type is void. So it has to be casted. Like here is a casting operation is done, integer, and because size of integer in most of the cases is 4 bytes. Most of the C compilers nowadays, very few compiler in 16-bit it may be 2 bytes. So 4 bytes and 520, and it will be has to be casted because the malloc return type is void. So it will be 20 bytes of memory, a large 20 bytes of memory. If not large, is a 20 bytes of memory. Block is dynamically allocated to pointer. Type versus void pointer with no specific data type. So it can be target, but whenever you dereferencing, it has to be casted. Type checking is not performed, so it is, you have to use very carefully. This is a pointer to pointer main. This is void pointer main, and this is a segmentation fault. If anything happens the pointer, because it actually goes to the actual address, you will get the segmentation fault in Linux and Unix machine. Pointer arithmetic depends on which kind of pointers. If it's a character pointer, it will be only 1 byte. And if it is a integer, it will be 4 byte. Like here, it is a character pointer, and it is a short, like 2 bytes. In short, integer is 2 bytes, is most of the case, and integer is 4 bytes. So here the address, it is but this pointer is basically the 4 bytes. This pointer is basically address. So here we can see it that character pointer is increased by only 1 and short by 2 bytes, and integer is by 4 bytes. So it depends on which kind of pointer it is. So next slide is double pointer. Pointer can address a pointer, like here we have a pointer here. It is this address goes here, is address. It is not preferred for actual some typical cases. We can have double pointer, we can more than one, but it should be used very judiciously. Otherwise, some error might come. Here you can see the integer variable 10, then pointer it is 20, and last it was, whenever I declare the pointer 30, the actual value changes to 30. This is interesting. Const, if you use the const, then you cannot change, like here, the const character suit, we cannot change the number of things, and here also we cannot change. This is like you are declaring a constant, like hearts, diamonds, clubs, space in a card scheme, you cannot change it. This is call by value, like whenever declare by 5, and how do you know that it's a call by value? By looking at the function, there is no such star here, no pointer is passed, and if the 5, and after the 5 it will return is 125, but value is always become 5. It's a call by value. So before passing 5 and you return get 125, but original 5 is retained. That's interesting. But call by reference, you can always see the function, there is a pointer, it is passed. Pointer is passed, and whatever is happening here, it reflects here. So here it will be 125 source and destination, both are 125. So actually single copy is there. So it saves the space of memory. So whenever you're passing very big array or image or video, call by reference is the preferred choice. It is much faster. But one have to be very careful. This is two other kinds of pointer. Dangling pointer, that whether the pointer actually it is already freed, but you are try to accessing it, then the error will come. A pointer becomes a dangling pointer when the memory location it points to is either non-existent or freed or already. So this is kind of error. We should not pointer whenever we have to definitely, you should not dereferencing a dangling pointer. Then your program once program will go to segmentation fault and severe error. And this is a null pointer. We should not dereference null pointer. And there is another kind of pointer, that is volatile pointer. That is volatile is a keyword. Whenever the real-time communication from a machine to say modem or say any other outside network to routers and all, that particular register variable in a CPU maybe take the crucial load, and you should declare as a volatile keyword. Volatile keyword, volatile keyword, and this thing should not be compromised in compiling and linking. So this is a volatile, another kind of pointer. And so here we discuss null pointer. Whenever you null should not be dereference. Void pointer is very useful, like malloc and calloc is always a void pointer. Void pointer, whenever you have to dereferencing, you have to cast it. And wild pointer and dangling pointer, same thing. Wild pointer, it can go to the any location in the memory. So we should be very careful of the wild pointer and dangling pointer. Most of the cases we will do null pointer, void pointer, and volatile pointer. Thanks for viewing.